Okay, welcome back again. And now we're going to talk about inlining functions. Now, a lot of times when you run a function, there's a performance cost. Well, actually, all the time. When you run a function, there is a performance cost associated with calling that function. This usually isn't a big deal because the cost is relatively minor. But if you have a tiny function that's just one or two lines, sometimes you can speed up your program by inlining that function. When you inline a function, you ask the compiler to make a copy of the function everywhere it's called. As a result, program control doesn't have to jump back and forth between different locations each time the function is called. We're going to create a program called Taking Damage that simulates what happens to a character's health as the character takes radiation damage. The character loses half of his health each round. The program only runs 3 rounds, so we're spared the sad end of the character. The character doesn't die. But the purpose of this is to show how we can inline the function that calculates that character's new health. So we'll go ahead and create a new text document. And I will save this as takingdamage.cpp. Have my introductory comments. And we'll include iostream. That should be the only library file that we need for this one. Okay, next we're going to declare a variable called radiation. Actually, this is a function called radiation, and we send it the integer health. Well, you know what? Your textbook does this out of order, in my opinion. And I don't want to do things out of order. I want to maintain my normal program template where I have my include, my directives, and then function prototypes. Okay, open my main function. And we'll declare an integer variable called health, and set it equal to 80. And then we'll report what the character's health is when the program begins. Okay, next we'll have 1 round of radiation damage. And we send the current health to our radiation function. And we'll report back what the new health is. Now for round 3. And that was round 2. Now round 3. Okay, that'll be the end of our main function, so we return 0. Now, to specify that you want a function inlined, you just put the word inline before the function definition. Remember, this is not the function definition. This is the function prototype. The function definition is where we actually define what the function does. So we want to inline this function. So we have inline int radiation, which receives as an argument the integer health, and this is going to return health divided by 2. And that's all that the function does, is it divides health by 2 and then returns that value back to the main function. Okay, now remember, in your function declaration, this is not where you put the inline statement. Okay, your function declaration is just the prototype. It's telling the program what to expect when that function is actually declared. In the actual definition, we have inline int radiation int health. By flagging this function with inline, you're asking the compiler to copy that function directly into whatever code is calling it. So what it does is, in this line, where it says health equals radiation health, it copies return health divided by 2 here. And then it copies it here, and it copies it here. That way, the program doesn't have to jump to another part of your code in order to call that function. This is really only useful for small functions. If you do this too much, it can actually lead to worse performance because it creates extra copies of that function. So if you have a function that's more than a couple of lines, you probably don't want to inline that function, especially if you're calling it 4, 5, or even more than 2 times. All right. When we call the function, it's no different just because it's inlined. We call it the same way. Health equals radiation with an argument of health. Okay, this assigns health 1/2 of its original value, and then here it assigns 1/2 of its new original value, and so on and so forth. So let's see how that works. We'll save and compile and run it. So starts off, health is 0, then it drops to 40, then 20, then 10. Okay, it doesn't look any different, but in a large program where you had just a one-line function, this could provide a significant performance boost to your program. Copying that function into the calling code stops the program from having to jump from one place to another, which is really important if you've got a larger program that might be dragged down by having to jump around. You want to be careful, it's important to look at your performance of your program, but you don't want to focus too much on speed. Most of the time, you will get your program working well before you start tweaking it for performance gains. And then you will use what's called a profiler that analyzes where the game program spends its time. And then if you see bottlenecks, then you might consider optimization like this function inlining in order to speed up the performance. It's not something you just want to do willy-nilly. You need to make sure that it's actually going to provide a benefit. And the best way to do that is by profiling it to see if there's actually a bottleneck jumping to those other functions. I'm not 100% sure, but I believe that Visual Studio Express does include a profiler. That's something that you might look at if you do more intense programming later on down the road. We won't cover profiling in the scope of this class. That's an advanced subject. It's not really part of an introductory course to C++ programming. That's something that you would get into after you're done with this course if you want to further your programming skills. So that's it for inlining functions, and hopefully that makes sense. As always, if you have any questions or problems, just shoot me an email. Thanks.